Hi everyone, I hope everything is going well from your side. This is the second video of local projection. The previous video we saw a little bit of what is the theory about this method, and today we are going to do an application of this local projection methodology on Stata. Okay? So first, what I want to make explicit is that this code is based on a Valerie Rami code, and that Valerie Rami code is also based on the Jorda code, original Jorda code of local projection method. So those codes are available in their websites, in Jorda and Valerie Rami websites. But also you can find this code that is a modification of those other codes in my website, my personal website, that you can find it down below. Okay. The most important modification that I did in this code is that I add a while bootstrap confidence band, and why I did that is that because I want a confidence band that is robust to heteroscedasticity. Okay, so first what we are going to do is to install the boot test package, because we are going to use that package for the while bootstrap confidence bands. Okay, then we are going to set a little bit of things in these 5 line of codes. They are not strictly necessary to run the codes, but it is only a thing that I do in most codes that I use. Okay, then we are going to set the folder, and we are going to import the dataset that also you can find it in the website. Okay, down below. So this is the first thing that we are going to use. Then what we are going to use are only 5 variables. Okay, because what we are going to do is to estimate the effect of a monetary policy shock into different variables. Let's say industrial production, consumer price index, 1-year rate, or excess bond premium. Okay, so we are going to have these 4 variables available, the industrial production and the consumer price index in logarithmic scale, because when we are capturing the coefficient in the estimations, then if you have the logarithmic scale of a variable, you will be capturing the percentage variation of that variable, and that is a really good estimate, a really good scale to work. Okay, perfect. So we will keep only those 4 variables, those 4 dependent variables of our estimation, and the shock. Okay, and what we are going to use as a monetary policy shock, we are going to construct a monetary policy shock proxy from the Fed fund future rate 3 months ahead. Okay, so what we are going to do is to take our Fed fund future rate 3 months ahead, and we are going to measure the change of this instrument 10 minutes before the monetary policy announcement and 20 minutes after the monetary policy announcement. So this change, we are going to capture this change, and we are going to construct the series, the monthly series of these changes. Okay, and another thing that I want to be explicit about is that this monetary policy shock proxy constructed by the 30-minute window around the monetary policy announcement is we can argue that this variable is a good independent variable of interest, because it will not be correlated with other changes or other shocks or other announcements in this 30-minute window. but at the same time that is not completely true, as we already saw in the previous video of local projection that we explained a little bit of theory. This variable will not contain all the information around the monetary policy shock, will only contain the part of information related with the monetary policy announcement, but for example will not contain the information related with the speeches of the fund members. Okay, so this variable will have a lot of pros to be a monetary policy shock proxy, but at the same time it is not the best, and that is why a lot of researchers nowadays they are using the IB local projection or instrumental variable local projections to use these type of theories as an instrument, okay, of the unobservable and truly shock, monetary policy shock. Okay, perfect. So we are going to let's move on with this simple local projection method and finish with it. So we are going to generate a variable that we contain the date in a monthly basis, okay, and we are going to construct a variable age that is going to be used in the graphs, so for plotting purposes only. Okay, after that we are going to create the variables that will store the coefficients of every estimation of local projections, and also the upper bound and the lower bound of our different estimations. Okay, perfect. The next thing that we are going to do is to set our shock. Okay, so we are going to use this variable that I set constructed around the monetary policy announcement, and also we are going to set some locals that we are going to use as lags of our variables and controls, independent variables of the shock, okay, and the controls. Okay, so the estimation itself will contain two loops. Will contain the loops that will have the horizons of the estimations, and also we will have the loop of our variables, our different independent variables. Okay, so you will see here that the loop itself will contain here the forward of the variable, the dependent variable at different horizons, and the different variables, okay, as dependent variables. And also one thing that is important to note is that we are going to use the Niue West estimation, because we want to have errors that they are not autocorrelated. Okay, so that's why also we will put as maximum lags of the estimations as the horizon plus 1. Okay, that is a standard value that you can see in a lot of papers that they use. Okay, perfect. So the estimation will follow this equation, and if you see carefully, that is the same equation that we can find in the previous video in the base equation here. Okay, so the dependent variables at different horizons, the constant, the independent variable of interest at time 0, and you can add some lags, and the control variables, and also with their lags. Okay, so you can see the same structure here. The the dependent variables at different horizons, okay, the forwards, the choke, okay, the independent variable of interest at time 0, and 2 lags of it. Then we will put controls, and the controls of this estimation will be our different dependent variables also, but their lags. Okay, so if you see, for example, this equation, so this coefficient is that this variable is the industrial production, but lag from lag -1 to -2. Okay, so from lag 1 to 2. Okay, so here we will have two variables: the industrial production of the period -1 and the industrial production of the period -2. Okay, so we will use the same thing for all the variables, and then we will do the estimation only for the period of from 1990s to 2012, month 6. Okay, that is the whole estimation that we will use. Okay, why we use these lags and not others? Well, you can argue this choice by information criteria, for example, and that is the standard for default. We can use that for arc. How many lags we will use in our estimation, and if we have to include controls or not. Okay, perfect. So then the only thing that we are going to use, we will going to store our coefficients of the different estimations at different horizon for different variables, dependent variables, and we will store also the confidence bands of upper bounds and lower bounds of our while bootstrap confidence bands. Okay, perfect. The only thing that is missing after that is the graph itself. So that is the last part, and for that we will use our series of lower bound, upper bound, our coefficients, and our auxiliary variable that we said before, that is our time. Okay, perfect. So I will run all of this and we will see what will happen. This code will run in some time, because we will have to estimate a lot of equations. Okay, as you are seeing right now, you are watching a lot of estimations for different horizons from 0 to 48, and then also for every dependent variable that we have 4. Okay, so there are a lot of estimation process running around right now. Okay, but after all these estimations, we will see the result, and we will talk a little bit why is the result like that. Okay, and we will compare it with the S-bar methodology. Okay, because there are a lot of difference, and there are some pros and cons of using local projections and structural bars. Okay, so you can see the result here, and you can see that these results are almost identical of what Valerie Rami has in her paper. Okay, so if we want to compare it with what she has, is almost the same thing. What is the difference? The difference you will find on the confidence bands, because the confidence bands that she has, they are simple. confidence bands, and what we have is our wild bootstraps confidence bands robust to heteroscedasticity. Okay? And then what I want to show you is that Valier-Rami shows that this exact estimation, but by S-bar and by local projections, they lead to completely different results. If you can see in the 1 year rate, you can see that in 20 periods ahead of the shock, after the shock, you can see that it's going down, and with the proxy S-bar methodology. And with the local projection methodology, you can see that 20 periods after the shock, it is still around going up. It's still going up. So that difference is problematic in a sense. And what she argues is that S-bars are quite precise if you are not doing or making any misspecification, because S-bars are completely vulnerable to misspecification because they capture only one coefficient, they only do one estimation, and then they with that coefficient they estimate the impulse response for the future. Okay, so if you are doing you are making a misspecification, you will find that misspecification will be amplified in the next periods. Okay, so for that reason, S-bars, you have to be very careful with what you are going to do and what you are going to provide as a base theory for the specification of the structural bars. In the other sense, in the other way, with local projections, they are completely flexible because they are not vulnerable to misspecification, because there is no a strong specification. So you are only letting the database talk. Okay, and that is a good thing because, as I said, this method is not vulnerable to misspecification, but at the same time, if you are not using a theory behind it, it is not completely intuitive to interpret the results of the local projections, and that is the cons. Okay, so when you are going to use structural bars and when you are going to use local projections, well, that is only is a choice that you have to choose with what you have. Okay, so if you have a strong theoretical model that is a really good one, and it could provide a strong basis to then interpret the results of the model, then the model that you have to use is the structural bar. Okay, you can use the proxy bar, the exogenous structural bar, or the Cholesky decomposition structural bar, but if you have a strong theoretical basis behind it, you can use it because it will be more precise. But if you are not, if you don't have a strong theoretical model behind it, then I will suggest that local projection is more flexible, and in fact it could be more less precise, but it will not be vulnerable to misspecification and will not amplify that error to the next periods and to the longer horizons, okay, as we can see on bars. Okay, so I think that is enough for today. I hope you could learn something about these models and the application of it. You can find the dataset that we used and also the code that we used today on the website down below. And of course, if you have any comment, any doubts, please comment down below and I will see them. Okay, so have a good one and see you later.